I would urge you to pause the video and try this one on your own. Average rate of change of y equals 2 over x on the interval from 5 to x would be f of x minus change in y, so f of 5 all over x minus 5. So what's f of x? Well, we already have that. What's f of 5? F of 5 is 2/5. So f of x is 2 over x. F of 5 is 2 over 5. And then we have over x minus 5. Now, so that's what we're taking the limit of. So we're taking the limit as x approaches 5 of this complex fraction. That's what we call it, a complex fraction when you have fractions in a fraction. And when you replace x with 5, you can see up on top you get 2/5 minus 2/5, that's 0. And then 5 minus 5 is also 0, indeterminate form. So we have to do something. So here's the I don't know, I guess my strategy would be, you don't have to do this, but this is a good thing to do. Get rid of the fractions within the fractions. When you see this happening, you want to reduce the number of fractions that we have. So we have 1, 2 fractions in the numerator, and then one big fraction here. So to reduce that to then just one big fraction, we want to multiply top and bottom by whatever is going to get rid of the denominators. So whatever is going to simplify the fraction a little bit. So we're going to multiply top and bottom by 5x. Therefore, the x and the 5 will cancel out, and then we won't have any more fractions in our numerator. So in doing this, we have to distribute the 5x to the first term. 5x times, let's do this. Let's do the whole thing. 2 over x times 5x, and then we have minus 2 over 5 times 5x. Leave the denominator factored. Do not multiply that out because you want things factored when you're finding limits. It's easier to do that. And then when we simplify the numerator, we can cancel the x's here and we can cancel the 5's over here. So when the dust settles a little bit, we've got 2 times 5, which is 10, minus 2 times x up on top. And then again, we have 5x times x minus 5. We're just simplifying the function. And then when we get it all simplified, then we'll find the limit. Now, we can see if we do plug in 5, normally this happens, plug in 5, we're still going to get 0 over 0. So we want to go ahead and factor out a 2 from the numerator. We get 2 times the quantity 5 minus x over 5x times x minus 5. Please don't be hasty here. Don't just cancel those. They're not the same because, what do we call that property? Commutative property is not... It does not work with subtraction. In other words, 5 minus x is not the same as x minus 5. However, if you do cancel them, you're left with a factor of -1. So we can cancel those, but make sure you leave a factor of -1, because now when this dust all settles, we're going to go ahead and rewrite our limit expression. So we have limit as x approaches 5. We're going to multiply the -1 times the 2, and we're going to get -2 over 5x. So we get, when we replace x with 5, we get -2 over 5 times 5 is 25. So that right there, that was it's a pretty advanced problem there, and I wanted you to make sure you had one of those examples in your notes so that when you get something like this, you get a fraction, you know what to do with it. So that's it.